Welcome back to my today's session on question bank discussion and problem solution of Unit 5. Myself Dr. Sayanti Chatterjee, and today I am going to discuss the some question bank problem from Unit 4, and Unit 4 is basically nothing but the magnetostatics. So today we will discuss the question from the force on the magnetostatics and magnetic field. Two mutually coupled coils are connected in series. L1 is equal to 0.5 Henry, L2 is equal to 0.6 Henry, and M is equal to 0.1 Henry. Current flowing through it is increasing at a rate of 1 ampere per second. Derive the expression for voltage induced in the coil when they are in the series aiding connection and when they are in the series opposing connection. So L1 is 0.5. Series aiding means we are connecting it with the series. The current is flowing and this current is flowing in the same direction. So L is equal to L1 plus L2 plus 2M. L is equal to L1 plus L2 plus 2M. So what is the value? The value is 0.5 plus 0.6 plus 0.2. So it is coming as 1.1 Henry. And what is the value of the EMF? EMF or voltage? The voltage is L di by dt. So is equal to 1.1. Di by dt is the rate of change of current is 1.1 into 1. So it is coming as the 1.1 volt. Similarly, if they are series opposing means 0.5 plus 0.6 minus 0.2 is equal to 0.9 volt. So what is the voltage? Voltage is equal to L di by dt is equal to 0.9 volt. So this is the problem 6. Problem 6 is the for the series and series aided connection and series opposing connection of an inductor. Now we are moving to our next problem, and the next problem is a solenoid with the 300 turns is 300 millimeter long and 30 mm in diameter. If the current is 500 milliampere, calculate the inductance and the energy stored in the solenoid. Assume that the mu r equals to 1. So we have a case study of a solenoid. The solenoid has the 300 turns and the turns is 300 millimeter long and the diameter is 30 mm. So you can think this is a solenoid, and on the solenoid the length of the solenoid is 300 mm. 300 mm means 0.3 m. And the diameter is 300. The L is equal to this. The diameter is 30 mm. So what is the radius? The radius is 0.15. Is 15 mm. Is equal to 15 into 10 to the power minus 3 meter. So some coils are connected on it. So already we wrote this number of turns. So number of turns is 300. D diameter is 13 to 10 to the power minus 4. The cross sectional area is either we can write pi r square or pi d square by 4. The length is 0.3 meter. So what is the inductance? Inductance value is mu naught n square A by L. Mu naught n square A by L for a solenoid. Mu naught is the permeability of the medium. N square is equal to number of turn. So if we put the value mu naught is equal to 300 square, mu naught is equal to 4 pi into 10 to the power minus 7 into 300 square into pi d square by 4. D value is 30 into 10 to the power minus 4 whole square by 4 into L. L is 0.3, and if you put all the value, you will get the value of 2.66 into 10 to the power minus 4 Henry, where the mu naught value has been taken as 4 pi into 10 to the power minus 7. There is another part, energy stored in the solenoid. What is the value of the energy stored? Is equal to half Li square. So half 2.66 into I, half Li value is given as 500 mA, means 0.5 whole square. Remember, always we will save the value, we will adjust the value in the SI unit. We never use the CGS unit, we will always use the meter unit, never we will use the CGS unit. So this is our problem 7, the energy stored in a solenoid. Now we are moving to our problem 8. This is a very important problem from this chapter. A rectangular loop of wire have a free space of 101 to B301, C304, D104 to N. So if we draw this, it is a rectangular wire with A, B, C, D. What is A? A is the value is 101. What is the value of the B? B value is 301. What is the value of C? C value is 304. And what is D? D is equal to 104. We have to, the wire carries a current of 6 milliampere. 6 milliampere. Flowing in the AZ direction, from B to C. From B to C. Sorry, so the current direction is not here. The current direction is from B to C, AZ direction, and it is 6 milliampere. 6 milliampere. A filamentary current is flowing along the entire axis. The total amount of current flowing in this axis is 15 ampere along with the Z direction. Find the force on the BC. So what is the formula? We will use here the B is equal, the force is equal to I dl cross B. I dl cross B. Because the force we want to calculate is in the B, we know that from the F is equal to I L cross B. We are using the same formula. So what is the value of the I we got? The I value we got before, it is 6 into 10 to the power minus 3. The current flowing in the BC direction is 6 into 10 to the power minus 3. What is L? L value we will take as dz. We will take the value of current is the dz into az. Into we will also take the az direction. So what is the this is our this is the force in the dl. So I dl. So dl value we are taking from B to C, only the Z direction. So it is 1 to 4. The current is flowing from B to C into 1 to 4. Now we have to calculate the B. What is B? B is the flux density for the total thing. So what is the formula? We know the formula is Ni by what is the H value is equal to Ni. So what is the value? So N number of turns is 1. So it is coming as mu naught Ni. Mu naught Ni is the B. Number of turns is equal to 1. So I is the, for this total line, the I is, we are taking it as a 15 ampere into mu naught. Mu naught is the 4 pi into 10 to the power minus 7 by 2 pi r. By 2 pi r. Why we are taking the 2 pi r value? Because the current always creates the flux in a circular. From the Ampere circuital law, we know that the current always creates the flux in a circular, and we are using that the I is equal to H by 2 pi r. We are using the same formula. So because we are calculating the force, so B is equal to 15 by 2 pi r. R is the 3. That point is the 3. So the r, the distance of this radius is 3. So 2 pi r, and it is in the AY direction. So we can, if we calculate it, we will get the value 1.8 into 10 to the power 8 into the n. N means minus 18 AXN, because AZ cross AY is equal to AN. AZ cross AY is equal to AN. Now this is another important problem of this chapter. Find the torque vector on a square loop having a corners of minus 220, 220, 220, minus 20. So there are 4 points. We have to calculate. Again we will use the formula torque. First is the force. What is force? Force is equal to BIL sin theta, and we are taking the maximum value of B. F equals to BIL sin theta. What is the value of B? The B value is given as 0.6 AX plus 0.4 AY Tesla. So these are the 4 points. How to get the L? If you calculate, we know end point to starting point, minus 2 minus 2. So it is 0, minus 2 plus 2, it is the 4 unit. So if we calculate, we will get the value is, all the values are in the 4 unit. So we can also know torque is equal to N B A into number of into I. So what is the number of turns? Number of turns is here not given, means 1. What is the value of B? 0.6 AX plus 0.4 AY into A. What is A? A value is the 4 square. 4 square means 16 into the value of the current is 0.5. So if we put the value, we can get the answer. Next, we are moving to the problem number 10. What is the problem number 10? A very long solenoid with 2 into 2 centimeter cross-sectional iron core has 4000 tons. If it carries 5 milliampere current and the permeability of the iron is 1000, then calculate the self-inductance and the energy stored. So a very long conductor means and it has some coils. So what is the inductor formula? N square mu naught L by A. So what is the value of the N square? N square is the number of turns. So we have to calculate the inductance per unit length. We have to calculate the So we have to calculate, we know L is equal to mu naught N square A by L. So what is the here? Length is not given, so we will take L is equal to 1 meter. Mu naught here actually it is not mu naught, it will come as mu. And it is mu naught mu r. What is the value of mu naught? 4 pi into 10 to the power minus 7. What is the value of mu r? Mu r value is given as 1000. What is the value of n square? N square is the 4000 square. 4000 square into A. A is the 2 into 2 centimeter. 2 into 2 centimeter means it is 4 centimeter square. So 4 into 10 to the power minus 4. So if we solve this equation, we will get the value of the inductance. If we solve this equation, we will calculate the formula of the, we will get the total inductance of the coil. So if we want to calculate the, we will get the Henry. So what is the energy stored? Half L I square. So L we will get I is equal to 500 milliampere. I is equal to 500 milliampere is equal to 0.5 amps. If we put the value, we will get the value of the inductance. So this is the problem number 10, and up to this is the problems of the question bank. I have again 3 more problems of the last 3 years question paper. So question number 11. Question number 11 is the question from the last year. 2 long parallel conductors carrying 100 amperes. If the conductors are separated by 200 mm, calculate the force per meter of each conductor. So already one same type of problem we have discussed, and the values are only different. This is the questions of the last year. So what is the force? Force is equal to mu I1 I2 by 2 pi d. So what is mu? Mu is 4 pi into 10 to the power minus 7. I1 I2 both are 100 by 2 pi into d is 200 millimeter means 0.2 meter. So it is 0.2 meter. So we can tell that the pi can cancel out 2, and 0.2 by 2 means 10. So 10 into 4 means 10 to the power minus 3. 10 into 10 to the power minus 3 means 0.01. And what is the unit? Actually this is not force, force per unit length. Force per unit length. So the value will come as Newton per meter. So already in the first problem, second or third problem, we have discussed the how we are getting this formula and everything. So please you can once go there and you can check it. How to get this value? The force per unit length is equal to 0.01 Newton per meter. So this is the problem number 11 and it was given in the last year. Next we will discuss about the problem 12. If the vector magnetic potential is given as A 10 by x square plus y square plus z square ux, obtain the magnetic flux density in the vector form. So we know that the magnetic flux density B is equal to curl of A. Curl of A means grad cross A. What is the meaning of grad? Grad means del by del x plus del by del y plus del by del z ax, ay, az of A. A value cross A. A is 10 by x square plus y square plus z square. Ux means nothing but the ax. So if we want to write it in the form, it is ax, ay, az. Del by del x, cross product. Del by del x, del by del y, del by del z. 10 x square plus y square plus z square 0, 0. So while we are calculating this, first ax value is 0. When we are calculating it is ay, so it is coming the value del by del y 10 by x square plus y square plus z square. Minus of minus plus and del by del z the first one is the del by del z plus del by del y 10 by x square plus y square plus z square ay and it is az. So if we solve this equation, if we do this differentiation, we will get to write it neatly. So what we are getting? Ax 0, 0. Next we are getting ay. What is ay? Ay means this 0 del by del z into 10 x square plus y square plus z square. Next we will do this del by del z means az minus of del by del z into 10 by x square plus y square plus z square. So this is the question number 12. Next is the problem number 13. It is a special problem. It came in the last year GATE exam. So an electron moving perpendicular to a uniform magnetic field 0.5 Tesla undergoes circular motion of radius of 2.80. What is the speed of the electron? So first we know charge of the electron is 1 minus 1.6 into 10 to the power minus 19 coulomb. So Q charge is equal to 1 minus 1.6 because we are writing only an electron. We are thinking about only one electron. So charge we are using Q is equal to V cross B, this formula. So what is Q? Q is equal to 1.6 into 10 to the power minus 19 coulomb. Now what is the magnetic field? The magnetic field is given as the 0.5 Tesla. So we have to calculate the velocity. How to calculate the velocity? the mass of the electron is 9.11 into 10 to the power minus 31 kg. So radius of the orbit, the radius, it is moving in a orbit of the 2.50 mm, it is going. So what is the velocity? Velocity is equal to q charge r radius into b. Q radius into b. So q value is given here. Radius is also given, rb by m. rb by m. Why we are getting this? Because we know F is equal to what is mass into what is force, mass into displacement. Thus, it is going in a circular path. Again, it is Q V cross B or VB sin theta, or we can write it Q VB sin theta. When it is maximum, we can write Q V into B is equal to M into R. So what is the value of the V? V we can get Q B R by M. If we put all the value, we can calculate V is equal to 1.6. We put the value, V will come 2.195 into 10 to the power 8 meter per second. So this is my today's discussion, and thank you. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.